Now here we will have another example of finding the derivative of the function using the four-step rule. So this is our example number 3, wherein the given is a rational function. So y equal to 3 over x squared. So similarly, using the four-step rule, we have to replace the y by y plus delta y and x by x plus delta x. So then, before we will simplify the step number 1, we can proceed to step number 2 here, wherein we have to subtract the given function from the derived equation or expression in step 1, or just simply transpose the y on the other side and it is now a minus y. Then when we substitute the value of the function y as 3 over x squared here, now as you can see here, we have a rational expression, and basically in order to simplify a rational expression is we have to use the LCD or the least common denominator. So finding the least common denominator is just simply the product of the two denominators as x squared to be multiplied by the quantity of x plus delta x raised to square. And then simplifying, we have the LCD divided by the new denominator of the first term multiplied by the numerator, so remaining now is 3x squared. Now on the second term, this is also the LCD divided by the denominator x squared multiplied by the numerator, so this is minus 3 times the quantity of x plus delta x raised to square. And then by simplifying the expression x plus delta x raised to square, so this is now x squared plus 2x delta x plus delta x squared, and then distribute the 3 here, so this is now negative 3x squared, negative 6x delta x, and negative 3 delta x squared. And then we can now combine the similar terms as 3x squared minus 3x squared, and that is 0. So remaining in the numerator is negative 6x delta x, negative 3 delta x squared. And then in the denominator part is still x squared times the quantity of x plus delta x squared. And then we can factor out the delta x as the common factor in the numerator. So we can factor out the negative delta x here to be multiplied by the quantity of 6x plus 3 delta x in the numerator. Now, the idea here is that we can factor out the delta x because the next step is we have to divide both sides by the delta x. So that's so easy to reduce with the delta x. And the idea here is that for the denominator part, no need to expand into binomial because we can remove the delta x in the step number 4. So let us proceed to step number 3. For step number 3, we have to divide both sides by delta x. So when we divide both sides by delta x, this is now delta x divided by delta x. So we have 1 in the right side. Now on the left side, this is now delta y divided by delta x, and then the right side, this is negative times quantity of 6x plus 3 delta x divided by the denominator part as x squared times the quantity of x plus delta x squared. And then the next step is we have to evaluate the delta y with respect to delta x for its limit as delta x approaches to 0, because this is now the derivative of the function with respect to x. So then, when we substitute the delta x as 0, so in the numerator part, delta x is 0 multiplied by 3, and that is 0. So remaining in the numerator is negative 6x. Now in the denominator part, when delta x is 0, so this is now x raised to square to be multiplied by x squared. And then finally, for the final answer, we have to simplify it again by reducing the x. So this is now negative 6 over x cubed. So we can say that derivative of the function y with respect to x is now equal to negative 6 over x cubed.